Hi class, it's me again. Hope you can finish your games code. But I think maybe you will have a difficult in modeling because we have a new technique need to show you in order to finish this model. Where is it? Guess. Is I and I prime here? No, because you can use the alias, right? If we have two symbols but they have the same meaning for sets, then we can use alias. ALIAS, right? In games. So we solve the problem. So where is the difficulty? Okay, I think here, right? Order I is not equal to order I prime. So we need to use what? Remember, we use it in TSP problem, right? Okay, we use what? We use dollars control to make I is not equal to I prime, right? If you are forgot how to model with the dollars control, you can follow with me to build the games model. Okay, and I suggest you to write down the model into the paper, then you can model it without switch the screen. Okay, just follow me. And please write down the model first. Okay, we have a minimize z equal to summation xi and subject to ei equal to si plus pi for every I, ei minus di less or equal to mxi for every I. Okay, and the ei less or equal than si prime plus m times 1 minus yii prime for every I prime, and I is not equal to I prime. And the other one is ei prime is less or equal to si plus m yii prime for every I prime. I is not equal to I prime. Okay, so please write down it, and then now we switch the screen to games. Okay, you open the games and open a new file here. Okay, so now we need to determine the index. We use the sets, right? So we have the sets I, 1, 2, 3. Okay. And because now we have I and I prime, so we use the alias. I use I1. Okay, you cannot use the prime, right? If you use the prime, something wrong. Okay, so we use the I1 instead of I prime. And then now you can make your parameter we have the pi and di, right? You can just make some number. For example, for the first one, we have P1 equals to 10. For the second one, P2 equals to 20. And for the third one, P3 is equal to 30. Okay, you just make some number for Pi and Di. And for Di, D1 equals to, let's see, 9, and D2 equals to 21, and the D3 equals to 10. When you set up this parameter, you will see at least one orders will be overdue, right? You can see for the third orders, okay, here the processing time is 30, but its due date is 10, which means if you start your orders at time 0, it will finish at the time 30. So at least you will know there is one order will be overdue. Okay. And can we put like the second one is after order 3? If we start with order 3, it's not good, right? Because the due date here, the second one is 21, and when you finish your order 3, right? When you finish your order 3, the time is already 30, so you will overdue again for the order 2, right? So in this case, maybe we can put like the first one and the second one and third one and so on. You just try the different sequence by your experience, and we will check the results for model output to see if this is the best schedule or not, right? Okay, so we need to define some variable. We have two binary variable for xi and yi prime, right? So we have binary variables xi and yi prime, right? And two different other variable for start time of the order I and the finish time of the order I. So we set it to positive variable for Si and Ei. And we need free variable for objective, right? So we have a free variable z. Okay, so now we can check anything lost. Okay, we have I for sets, pi di for parameter. We have the xi, yi, I prime for binary variable, and si and ei for positive variable, and we have free variable for z, right? Okay, so nothing is lost. Okay, so we can determine our objective, and we have 4 different constraints, right? So for the first one is the relationship between the finish time and start time of the order I, okay, here, right? So we have maybe I just call it a relationship. And for the second constraint is to determine the overdue, right, of the order I. Okay, so we have the EI, we say overdue for I. And for the third constraint and fourth constraint are either or constraint. Okay, determine the sequence for the order. So we have the maybe sequence, call it sequence I prime. Okay, we can determine the name of the objective and the constraint. And then now we need to determine the objective and constraint. So for the first one, we want to minimize overdue. So here is z equal sum I xi, right? And for the relationship is finish time equal to start time plus processing time. And for the overdue, when ei minus di is positive value, then it will become overdue, right? Otherwise, it is not. Okay, so the value for the xi would be 0 and 1, and we want to minimize the problem. So the program will choose the smaller number, so xi will be equal to 0, right? So we use the 1 power 6 to represent a very big number for xi. Okay. And for the sequence, the first sequence, right? First sequence is ei dash then si prime plus big M times 1 minus yi prime, right? And the other one is I prime that's then si plus 6 times y. Okay, so do we finish the model or not? Actually, it's not, right? You maybe already see here we have for all I and I prime, right? Here we have all I and I prime, right? But where is this one? I is not equal to I prime. Where is that? No, right? So we need to use dollars control to make the I and I1 are different. So we use the dollars control here. And then we use the ORD I not equal ORD I1. Okay. So here is the same for the sequence 2. So what is ORD? It's the order, not this order is not that order. Okay? Maybe I say order I means the product I. Sorry for that. Mismatch the name of the problem. Okay, so ORDI means the order of the set I. Okay, so if I equals to 1, the sequence or the order of the I is equal to 1. Okay, so here if the I equals to 1, okay, and I1 cannot equal to 1, it should be 2 or 3, okay. So when these numbers are not the same, then we have the constraint validate. Otherwise, it is not correct. Okay. So we finish the models, and then we can run the model. Okay. So we give the model a name. Is overdue? No, you cannot use the overdue. It's called okay, check overdue. Okay. And then we say we want to solve. Oh, solve. Check overdue using MIP. Remember, you cannot use LP because now we have the 0, 1 variable, right? So we need to use the MIP solver. Minimizing C. Okay, so let's check if this is correct or not. Oh, it's correct. Okay, so we can see the best sequence actually should be, I guess, should be 2, 1, 3 or 2, 3, 1. We need to see the start time of the product, right, or the orders. Okay, so the start time of the second order is 0. Once it's finished, then start with the first one, okay, then the third one. Okay, so you can try to arrange the sequence of the 6 different sequences to see if you can make the overdue equals to 1. Okay, you can by any kinds of ways, the rules, or you want to list all the secrets, it depends on you. But if we have something like not only 3 different orders, it becomes trouble, right? If we have the 10 orders, if we have 20 orders, you can try to do that by yourself. Okay, so you will know to build a mathematical model has a lot of advantage and save our time if the number of the order is getting larger. Okay, so finally I want to do some extension like what I said. You can extend your numbers of order, or you might have n parallel machine instead of just one machine. When you use the n parallel machine, normally we will use the max band or tardiness or others objective for our problem. And you might think of that, why we don't use the max band for one machine scheduling problem. You might think about that. If the max band can works or not, it definitely can works. But what is the result? Okay, why I choose the overdue instead of max band? Okay, you can try for that. And also you can try to make a model to do the n-stage production process. Okay, that means within each stage, okay, we have an n parallel machine, maybe n1, and stage 2 we have the n2. Okay, so this type of model, you can think about it, will become very complicated, right? we have number of orders and number of machine and number of stage. And if for each order, okay, it has different production sequence, then what will happen? What your model will be, okay? So you will know your problems are getting complicated and complicated and complicated, okay? And if you can build this kind of scheduling with different type, then you will success in mathematical modeling. At least, I think this is a very good training for you to build this kind of model by yourself. Okay, so this is a lecture for Lab 2. We practice the either-or constraint and one machine scheduling problem. And I explained some of the extension for you. You might try that by yourself. Okay, so if you have any question for scheduling and for the model building, okay, so you can send me the email. We can discuss with that. Okay, I can give you more hints to do the modeling. Okay, so see you next time. Bye bye.